The focus of this lesson is automobile ads. Example 1. The cost of an automobile ad is determined by its length. John plans to sell his car and places a 5-line ad in an auto enthusiast publication. The publication charges $31 for the first 2 lines and $6 per line to run the ad for 1 week. What will John's ad cost to run for 2 weeks? So I believe the simplest way to start this is to create a table that shows us the cost for various numbers of lines. So we're going to make a T table, and we're going to put on our left side the number of lines, and then on the right, let's put the cost. All right, so if I have a 1-line ad, that's only going to cost me $31 because it says right here, they charge $31 for the first 2 lines. If I have 2 lines, that's still a total of $31, okay? If I have 3 lines, it says I'm going to be charged $6 per extra line, okay? So I have 31 plus 6, or $37. If I have 4 lines, that's 31 plus 6 2 times, right? So that is 31 plus 12, or $43. If I have 5 lines, that'll be 31 plus 6 times 3, which is going to be 31 plus 18, or $49. Okay? Now, the question is what will it cost his ad to run for 2 weeks? So let's start with just 1 week. So what I have in this table represents 1 week. So John is running an ad that is 5 lines in length, okay? So we're focused on this row of our table. So we know that in order for him to run his ad for 1 week is $49, okay? So the cost for 1 week is $49. Now, because he's doing this for 2 weeks, we're simply going to multiply this by 2, okay? So the cost for 2 weeks is going to be given by taking 49 and multiplying it by 2. Okay, so we can see then that it will be $98 for him to run his ad for 2 weeks. All right, now it's your turn to try. Try this. Ramon plans to sell his car and places an ad with X lines. The newspaper charges Y dollars for the first G lines and P dollars per extra line to run the ad for a week. If X is greater than G, express the cost of running the ad for a week. Now note this is an algebraic expression, so work it out just like we did in example 1, but use the variables instead. Ask me questions if you have them. Example 2. Jason works for the Glen Oak News and is writing a program to compute ad costs. He needs to enter an algebraic representation of the costs of an ad. His company charges $42.50 for up to 5 lines for an automotive ad. Each additional line costs $7. Express the cost of an ad with X lines as a function of X algebraically. All right, we're going to start this very similarly to the previous one. Okay, so we're going to make our T table, and we're going to put lines, and then we're going to put the cost. The best way to create an algebraic function is really to look at patterns. So in the case of Jason's company, Glen Oak News, we know that lines 1, 2, 3, 4, and 5 all have the exact same cost, right? $42.50. So regardless of the number we choose, for lines 1 through 5, the cost remains the same. But we do know that if we go up to 6 lines, we still have to pay that $42.50 for the first lines with an additional cost of $7. Okay? If we go to 7 lines, then we'll pay that $42.50 plus an additional $7, right? So 7 times 2. And if we go up to 8 lines, we'll pay that $42.50 plus $7 3 times. Now, what we're looking for is a pattern, right? So we see that if we treat the lines as x and our cost as f of x, we are going to look for a relationship and try to figure out what would represent x on our f of x side, right? So I'm going to ignore for a minute lines 1 through 5 because those are all the same. And I'm going to focus solely on lines 6 through 8. Now, if I look at lines 7 and 8, they both have a 7 times something. 7 times 2, 7 times 3. So I'm going to assume that line 6 is 7 times 1, right? Which is the same as 7. So what is the relationship between the number of lines and, well, the number of sevens, right? So if we look at line 6, we see that there's a 6 and then a 1 7. And then in line 7, we have 7, and then we only have 2 sevens. And then line 8, we have 3 sevens being added on. So the relationship I'm seeing is that the number of sevens we get is 5 less than the number of lines. So this here is 6 minus 5. This here is 7 minus 5. This here is 8 minus 5. So if I continue this pattern and I extend my table down further and I get to the point where I have lines and then my cost, right, my x and f of x, and I just have x lines, we know that it must have this 4250 plus 7 times, and if we look at this pattern, it's the number of lines minus 5, number of lines minus 5, it'll be 7 times x minus 5. So if I have x lines, then I will pay 4250 plus $7 times x minus 5. So to write this as a function, we are going to say that f of x, the cost, is equal to 4250 plus 7 times x minus 5. Now we have to be careful here because that's not a complete response, right? Because if I have less than 5 lines, I have a different result. So here's what we're going to say. I'm going to modify this just slightly. We're going to be creating what is called a piecewise function. Now, a piecewise function says the rule is slightly different depending on the input. So we're going to say here that we have f of x, and that's going to equal, and this is just this bracket here, this curly bracket just says it equals multiple things. It equals multiple pieces. We're going to say it equals 4250 when x is less than or equal to 5 lines. And then we're going to say it's equal to 4250 plus 7 times x minus 5 whenever we have more than 5 lines. So x is greater than 5. And so that means this here, that's our piecewise function. That is our algebraic representation of the cost. So the cost is 4250 when we have less than or equal to 5 lines, and then it's 4250 plus 7 more for every line above those 5 lines when we have greater than 5 lines. Now it's your turn to try. Try this. The Smithtown News charges $38 for a classified ad that is 4 or fewer lines long. Each line above 4 lines costs an additional $6.25. Express the cost of an ad as a piecewise function. Example 3. Roxanne set up the following piecewise function, which represents the cost of an automotive ad from her hometown newspaper. C of x is equal to 41.55 when x is less than or equal to 6, or 41.55 plus 550 times x minus 6 when x is greater than 6. If x is the number of lines in the ad, use words to express the price, C of x, of an automotive ad from this paper. Okay, so we've kind of already done it in saying the problem itself, but we're going to try to elaborate. So we're going to say the cost, well, we say this. All right, it costs $41.50 for the first 6 lines and $5.50 for each line over 6. And that's it. We've expressed it in words. All right, now it's your turn to try. Try this. The following piecewise function gives the price P of W of a classified ad in a classic car magazine. If W is the number of lines in the ad, use words to express the price P of W of a classified ad from this paper. P of W equals 60 when W is less than or equal to 5, or 60 plus 8 times W minus 5 when W is greater than 5. All right, example 4. Graph the piecewise function Roxanne created in example 3. All right, so first thing we need to recognize is to create a table of values that will be easy to graph. So if we follow kind of the same idea as what we did before, where we have x and c of x, right? We have here our a number of lines as x and the c of x representing the cost, right? We can see here that the first 6 lines are all going to be that 41.55, right? So 1, 2, 3, 4, 5, 6 will all be 41.55. 41.55, 41.55, and so on, right? So if we're going to plot those points on the graph, we could see that they will all be the same. Okay, when we get to line 7, we know it's 41.55 plus 5.50. So that's going to take us up to, what is that going to be? 47.05, right? So 47.05. And then we would add another 5.50 and so on. So let's just get a quick sketch of what this is going to look like. So x is the number of lines, and c of x, that's our cost. So if we have between 1 and 6 lines, so 1, 2, 3, 4, 5, 6, the cost is the same value, right? This 41.55, right? So it stays literally flat, right? 1 through 6 actually, right? Then we hit 7 and it goes up by $5.50 to this new, right? This 47.05. So it's going to jump up. Now, because it's increasing by 5.50 every single time, it's going to have a consistent slope, right? So it's going to go up. Let's see if I can draw this straight. It's going to go up by that same rate all the way. And there's our sketch, right? So we know that the slope of this line over here, right, is this 5.50, right, up $5.50 over one line. And that, of course, the slope here in this section is 0 because the price doesn't change as we increase the number of lines. All right, now with this type of piecewise function, this point here in which we change from that 0 slope to that slope of 5.50, this is mathematically referred to as the cusp. In this case, our cusp is located at 6 lines, 41.55. Now it's your turn to try. Try this. Find the coordinates of the cusp of the graph of the following piecewise function. C of x is equal to 42.50 when x is less than or equal to 5, or 42.50 plus 7 times x minus 5 when x is greater than 5.